So let's talking about using our discovered services and application data to actually build a business application or group of hosts based upon their communications. There's a few places you can start here from that, but where I like to really drive users to look at, and it's typically easier to think about, is pick a device server in the environment that you're familiar with and look at the type of communications and type of application connections that you know exist on it and validate the data that's been captured. So I'm going to go to a MySQL Linux host. So we know as part of its naming convention, it runs MySQL, and I want to start validating a few things from that. There's a few places you can start. Of course, there are services. These are going to be looking at the running processes that exist on that system. So we know MySQL is a listening service. We can see the path that is executed from, the state, user context it runs on. I want to actually look at who is talking to that, what is its impact or dependency for this device. And I can start to view that from the topology. If I want to work in a visual, the topology is a good place to go for that. This is a relatively engineering focused view. So it is important to keep in mind that this is really where you're starting that application mapping journey, and it's not going to be the finished result of what your application would necessarily look like. This is where you can pull up any workload and see what services exist, what type of communications and ports does it listen on. So a few things are happening here. The topology always looks at just the first immediate one-to-one connections talking to that host. So if I open that legend, there's going to be a few different items here. We have our target device highlighted in this brownish color. And that's where I loaded the topology from. So if I went back, clicked on topology from that device view, that's our target device. And a few things within that grouping, we have this blip in its tannish color. This is indicating that a MySQL application component was discovered, which has its own app page. So common installation, device for two automatically knows what MySQL is. We discover that. We found it had a MySQL service, and all their services are in purple. And these have the different connection information. So we can actually see for MySQL, it has a remote service here called D42SPSIM sending data to that, and that runs on a host with Tomcat as part of the name. Now, if I mouse over these device names, you'll notice menus start to expand where I can go and view their topology or their device page, or I can expand them, and that's actually going to further branch out that relationship. And you'll notice a few things happen here. I now have additional connections and data in that group. So if it had additional relationships, I'm essentially hopping from MySQL, which then had this host running that D42SPSIM, and it's saying, show me who that communicates with. So it's expanding out the visibility within that topology view, and that had a host called Apache part of that stream, and we could probably assume, considering Apache is part of the name, it is running Apache web service as well, and that's the role it acts in. And now it's starting to grow quite a bit and get a bit more complex. I'm going to start to expand that out and zoom out a bit further so we can look at those components. So there's two different views here. There's our global view, which is simply just what host names exist and the directionality that they're talking to each other. So we see on Apache, these are all different clients sending data to that, and they're probably accessing the website and the HTTP service, and we can actually validate that in the local view. So the local view actually goes into more detail of what connections exist, who is communicating to each other, and what service is it on. And I can mouse over HTTPD service here, and I'll say go to the service page. I want to learn more about that. I can actually see it's bound to just a local IP address interface there. It's listening on port 80, and these are the clients connecting to that, as well as the path it was executed from. And it actually ties to that Apache HTTP application component. So there was a common application that we found it related to. If it was sending data, instead it may have a client section here where we can see what port it sends from and who it's sending to. So if it actually talked to middleware or a SQL database that that service was sending to, you would see that. In this case, HTTPD is just listening and receiving connections. So this information shows all communication that exists, and it helps me validate that MySQL is running on the system. It connects to a host running Tomcat as our middleware and another host running Apache that listens for HTTPD. This is still not necessarily a business application or a business service, but it could be components and elements of it. This will require interviewing and understanding of your environment to know that, okay, this MySQL host that runs at this path, well, based upon information in our environment, I know this network is used for our production applications and that our payroll application uses MySQL. Well, great. I now have started to define some of that, but there might be many MySQL instances that might be used for multiple applications. So I might need to talk with the business a bit further to really understand what type of applications exist, what hosts are they on, to validate the data that's been discovered. Because what's important to realize with Device 42, it's still all system-aware information, and we're revealing data that the system knows to help you make those decisions. Now, some things you can use to help identify those business relevant services is reporting on this data in Excel or CSV formats that give you this data in bulk to help make those decisions and flag these different items. One can be created from here, and this is what we call our service dependencies report. And I'll go ahead and generate this. Now, running that report from that topology view as I did limits just to include the connections from the devices in that view. So I could run that service dependency report and get every connection that was discovered in the database. But in this case, I just wanted to limit to that visual. So I can actually go in and look at what type of services and connections exist. So we have an SSHD service here. This is really not application relevant at all, and I could probably ignore that. Maybe I add a new column here to flag and ignore that later inside of device 42. But then I have things for Java, MySQL that are application relevant, and I can flag those as important. What I can start to do with that is use that data to identify what should I care about. So looking at this view, there's a few actions I can actually take from here. So I can look at any service and star that service. What that does is anytime it sees that service name at that path, so anytime we have opt rchttbd executed at that path, it could be different installations unique to that application. We do have two different instances of that D42 SP SIM service at different path. One was a simulation, one was a client. We starred them differently, but anytime we see that same service name now, device 42 is going to deem that important. That doesn't become immediately visible in the topology, but it will in the affinity groups, which I'll show in a moment. So as we see, MySQL or again Java is a good example as well, where Java could be used for client applications. Maybe there's just some software running that requires Java, but it's really not application relevant. But we may have things like IBM Cognos or Oracle Hyperion that use Java as a service for their applications, and those are important to us. I can star those unique instances of that. I could even just star the service name. So anytime we see Java as a service name, just deem that as important. When device 42 runs discovery, it's going to immediately be flagging things that tie to an application component like MySQL, Tomcat, Apache. These are known services that tie to an application. They're always going to be deemed important without user intervention. So a good place to validate that is within apps and service instances or services. So here I'll notice a few different items. There's topology status. So when I was talking about starred, that's what it's changing. I can set that to be starred or hidden. So like the SSHD service that I don't care about, I can set that to hidden so it's not included in the visuals, and I can use that to filter out data in reports. Or we have pinned, which device 42 really only sets pin services to your backend applications. So think MySQL, MS SQL, Oracle. From a pin service, what we say is this service acts as a listener. And anytime it has a client connecting to that, deem that as important and calculate an impact route from that. So we try to look at the backend first and build out the impact of Affinity Group from that database. So if I look at any of the pin services, there's going to only be a limited set of them. So we have a lot of Postgres services here. If I were to go further, we'll probably see Oracle and MS SQL that are pinned because they're database services. If there is a custom service in your environment that acts as a dependency for many applications, so a lot of other applications connect to it, and it's not something device 42 would see before, I could go in and star that. So if I want to say that this particular service here running on these LPARs, this is actually used for some of our applications, and I want you to calculate dependencies and impacts for any clients of that. I can then set that to pinned, and anytime we then see that service instance name, it's going to automatically be deemed as important and calculate the impact from that. And that is all dictating how our affinity groups are calculating. So the affinity groups, this is going to be refining that topology view even further. So that topology view, as you noticed, we had to expand out those relationships individually, and it includes all communication. So I'm going to pull up the affinity group chart for that same device that we were looking at a moment ago. So here's that MySQL system, and we now notice there's quite a few relationships and hops expanded out all the way. We actually don't have to individually select those and expand them out. And if I click on any relationship, it's going to show what the communication is. So here's our star D42 SIM service that we deemed as important that is being shown as a client to that MySQL application. And I can look at some of these other streams and see again, there's my Tomcat and Apache service. And this is what device 42 would have automated because it saw MySQL as a database service and is automatically calculating the impact of that. And it's grouping that a bit further. So anytime as we discover these connections and services that are application relevant or have been pinned or starred, it's automatically going to create these impacts and dependency groups for the different affinity groups. And these are time series based and sensitive over time. So I can actually look at right now as it loads, it's pulling up what it immediately looks like today. But I can go back, I'll say, what did this look like in October of last year? And actually see it was a lot less complex. It was just those Linux hosts that made up my application that I recognized. Later, I maybe hear about that there are some performance issues on this given application host, and I want to go to Affinity Group and look at it, and I see actually, all right, there's quite a lot more complexity now. This MySQL host now has 3 different middleware on it, and a lot of other clients connecting to that, and we're noticing it's underperforming quite a bit. Well, we might need to extend the resources out. Maybe it went through some change control that wasn't documented, and someone's now connecting a development or QA system to a production database, and it was never revealed why that happened. But this device 42 is discovering that. That can be made visible here. There's also abilities to report and have notifications for events like that, which we'll talk separately. But with this affinity group, this is getting me further to looking at those application relevant streams and as an end result, getting to my business application. So I know this host is running MySQL. I talked about it briefly being part of our payroll application, and we can see a few different components of that. So these Tomcat and Apache hosts are all part of my payroll app. But these hosts, through some interviews with the app owners, we actually found that this is for our CRM, and this is a development host that we really don't care about, but it was connecting to a database on that system. What I can then do to really remove that, because again, this is all systemware data, I'm going to go to a business application and I can model that a bit further. And I want to isolate it to that particular application. So I'll say this is going to be payroll. I'll search by that affinity group, search the name, and pull that up. And now we have all those same hosts in this particular view. Well, let me go ahead and highlight my payroll hosts that I care about. I'm going to fill them with red to indicate that these are my production payroll systems. And those that are part of the CRM, well, I actually want to remove them. They're going to be built into a different business application view. And same with this development QA host. I don't really care about that. Now I can see my production applications and clients connecting to that, where I can start to annotate and add relationships to that. So we just took discovered data, which was in a raw format in the topology showing all communications, refine that a bit further with the affinity groups, which is helping calculate and eliminate some of that noise, and then build that into a business application that's more relevant for app owners and business services. Now let me go back to affinity groups, and there's a few key pieces I wanted to talk about here as well. So to first start getting these calculated, they aren't going to be created by default automatically. You do have to go to apps affinity groups and click on configure like I just did to then enable that, which by default it runs on a schedule of once a day at 2 a.m. However, you can have them calculated immediately on demand by selecting the process now whenever you need them to generate. They do take some time to run. By default, it's also only going to generate impact groups. So Device42 likes to calculate the groupings based upon those backend or pinned listening services. So we're going to automatically look at databases and services, but as you build out what is pinned or starred, it's going to calculate the groups from that information that you've provided as well. I could also generate impact and dependency groups, and a dependency group is really just the reverse of an impact. So they're not going to be calculated separately. It's just going to take that impact stream and separate that out to its own dependency. So instead, I can look up a web server or middleware server. So I'll pull up the dependency of our Apache and notice that it's a lot less complex than the impact view because the Apache host didn't really care about anything else in that view. It just accesses that middleware, which then accesses that MySQL database. Although we know that MySQL then streams out to quite a few other hosts, but really they have no relationship to that Apache web server. So if you need to get a view of what's above that website running on that web server or middleware or other downstream client, that's what the dependency group can be useful for. But primarily, if it's migration use cases or you're looking to see who is impacted by a host, you're going to be working in an impact group. Going back to that configuration page, by default it is using a saved local query. And in most cases, you don't need to modify these. You'll notice it's pulling in all of my saved local that I have here, but it's going to be using the D42 Affinity dependency data. This is a default saved local query that looks at all the service connections that have been discovered in the past 30 days. I can set a custom one, which may be beneficial to consider non-standard use cases. In the case of our environment, we were not filtering by time. So we actually wanted to include everything historically discovered in our affinity group calculation and not just what was in the past 30 days. So if I want to create or change the affinity group query, I can go to Tools, Integrations, and Saved Local and find all my saved local here. And I can go to the D42 affinity dependency data and copy that to start with that as a baseline. Or I can write a new one from scratch, including that view. So if you're familiar with SQL and the context of that, we do have a data dictionary and ERD where you can manipulate and modify that. But typically you can just stick with the default, maybe even remove just some of these where clauses to include all data or just the past 30 days. Usually in an assessment or project, we generally recommend when affinity groups are initially calculating, just include the connections in the last 30 days so they're more manageable. But wanted to point that out if there are more edge use cases where you need to manipulate things. And in some use cases, it can be beneficial where you don't want to include client OSs or containers and things like that. We can modify the DOCL to ignore some of those hosts as we're calculating the affinity groups where it might be relevant.